Okay, this is a short video clip to show you how to use this piece of equipment safely. There's a couple of safety points that we should acknowledge straight away. This is an evacuated glass tube, which means it's got very low pressure gas inside, so if you gave it a real thump it would crack and implode, which would be very messy, so try not to knock it. And over here we've got a power pack that does 350 volts. Okay, that's to that wire there and that wire there. Okay, the wires have got, they're not exposed, they've got bits of tape over them, so it should be safe, but just make sure that you don't unplug any of these. Okay, you don't need to do that at all during the experiment. Okay, so the first thing to do is to turn it on, and then if you look over here you can see absolutely nothing happens. Alright, that's because the little electron gun in there is taking time to heat up. It takes about a minute. You can see it's just starting to glow now. While we're waiting for that, let's have a look and see what we've got to measure in this experiment. There's the formula that we're trying to plug the things into so that we can calculate E over m, the charge over mass ratio for an electron. So the first thing that we need is the accelerating potential difference in volts, and you can measure that using this voltmeter here. Just make sure that this switch is slid over to the right hand side. Okay, and you can see that we can twiddle this and change the voltage here. Okay, about 300 volts is the right thing, and you can see, there we go, you can see the trace there as the electrons are colliding with the low pressure gas molecules inside the evacuated tube and ionizing them and giving that nice blue beam. At the moment it's moving straight because there's no magnetic field, but if we go over to this power pack here and turn that on, in the coils here, okay, the current is now flowing, which is making a uniform magnetic field between those two coils and makes the electrons move in a circle. If you go back to the formula, you can see that you need to measure the magnetic field strength. Okay, and we can do that by using the LabQuest, okay, connected with the magnetic field sensor. So turn it on, and then if you look at the tip, okay, you want the tip to be oriented along the magnetic field. It seems to work best if you put it, give the most accurate value if you put it just at the side of the coil, as you can see I'm doing there. If you put it in the middle, it gives a slightly too low a reading. Obviously what we really want to do is we want to measure the magnetic field right where that blue beam is. Okay, but that's not possible, so this seems to give about the best approximation that I've worked out. If you change the voltage here, you can change the size of the circle, change the radius of the circle that it's moving in. Okay, not too big or it'll go outside the tube. Okay, and not too small because then it'll be really difficult to measure. So try and fill the tube approximately. Okay, and then the final thing that we need to measure is the radius of the circle that the electrons move in. Whoops, and you can see because I was talking a bit too long, the heater's just overheated there. If that happens, turn it off, okay, wait a couple of minutes, and then you can have another go at it. And all you're going to do is put the ruler at the side and try and get an estimate of the radius of the circle that the electrons are moving in. Okay, that's about it. Work safely and don't touch any of those wires.